Right, so just going to run through some of these questions on determining equations of polynomials. First thing you want to do, identify the x-intercepts and then use our factor theorem. Remember the factor theorem. Let's just do a little reminder of what that is for the first one. So if P of A equals 0, then x minus A is a factor of P of x, where P of x is some polynomial. So in this case, I know that P of x is going to equal some sort of polynomial in the form of x. Now when I go x minus negative 3, that's going to be x plus 3. So just using the intercept. The next intercept was at 1. That must mean x minus 1 is a factor. And then, again, when the polynomial is equal to 0, this time 3 is the x value, so I'm going to have x minus 3 as a factor. And all I need to do is figure out what this coefficient at the front is. And to do that, I use whatever other point I've been given. In this case, I've been given the point 0 and 2.25. That's the way Desmos wrote it. I would probably write it as 9 over 4 in the exam, but it could be either. So I'm going to use that. I'm going to say substitute the point 0 and 9 over 4 to solve for A. So when the polynomial, the value of the polynomial is 9 over 4, I'm going to have A, and then all the x's are 0, so this is going to be 3 times negative 1 times negative 3. So 9 over 4 is going to equal 9a. If I divide each side by 9, gives me a equals 1/4. So the equation of the polynomial is 1/4 x plus 3, x minus 1, x minus 3. No need to go any further and expand that. We're only going to introduce errors. It's much easier to work with a factorised cubic anyway. So that's how we want to leave it. Let's go again on the next one. Okay, so this time I've got intercepts at negative 4 at x equals 2 and x equals 3. So I'm going to start by going, let the polynomial be p of x. So p of x is going to equal some multiple of x plus 4, x minus 2, and x minus 3. This time I've got the point, again I've given you the intercept here, 0, 3. So substitute in 0, 3 to solve for A. So 3 is going to equal A times 4 times negative 2 times negative 3. I believe that's going to make us 24a, and 3 over 24 is 1/8. So 1/8 equals A. Therefore P of x equals 1/8 x plus 4, x minus 2, x minus 3. Now you might write those brackets in a different order, but it's still the same answer, still equivalent. Oh, another one here. This time it's interesting. I've got a repeated root. You can see there that rather than going up through the axis and down again, it's actually turning around at the axis. That happens when one of the factors is repeated. So for this one, I know that P of x, again I'd write something like let the polynomial be P of x. P of x is going to be some multiple of, so when x is negative 2, then x minus negative 2 is x plus 2. And because it's a repeated root, that happens twice. Gets a squared. And then the other one, when it's x minus 0, well that's just x. So I substitute that in. This time, substituting in the y-intercept isn't going to help me. I'll just get 0 equals 0 on each side. So I use the other point they've given us there, 2, 16. So I'm going to substitute in 2, 16 to solve for A. So 16 is going to equal A another 2. 2 plus 2 is 4. When I square it is 16 times 2 is 32. 16 divided by 32, 1/2 equals A. Therefore, P of x, and now I'm going to write it as a half x plus 2 all squared. If you want to write it as x over 2, x plus 2 all squared, or even x times x plus 2 all squared all over 2, they're all going to be right. We're going to be happy with any of those. Another one here, let's identify my intercepts. Checking the scaling, this is the point 3, so I'm going to have P of x equals A, x plus 4, x plus 2, and x minus 3. The point I have to read off the graph here, looking at the scale, that's actually 1.5 or 3 over 2, that point. So I'm going to substitute in 0, 3 over 2 to solve for A. A times 4 times 2 times negative 3. 3 over 2 equals negative 24A. So I've got to divide by negative 24, so that's 3 over negative 48 equals A, or negative 1 over 16 equals A. So P of x is going to be negative 1 over 16 x plus 4, x plus 2, x minus 3. Again, a negative coefficient of the xq term, a negative a value in front, you can see that it's going to go decrease as x increases towards infinity, because if I cube a positive number as it gets bigger, that just becomes massively cubic, and then when I put a negative in front of it, enormously negative. So you can see the negative ones go downhill overall from left to right. This one here doesn't look like a cubic. I would probably tell you that it was a quartic, so it's got an x to the power of 4, but I've got 4 roots, so again I'm just going to work with my polynomial like that. So P of x, and I use the intercepts, it works the same way. Some multiple of x plus 2, x plus 1, x minus 1, and x minus 3. Now it looks like I could use possibly, well, maybe that's not quite a turning point, but I've definitely been given a marked point here, so let's use that. Substitute in 2, negative 3 to solve for A. So negative 3 equals A. I'm going to substitute in 2, I'm actually going to get 4, 3, 1, and negative 1. So negative 3 equals negative 12A. Divide by negative 12, and I get 1/4 equals A. Therefore, P of x equals 1/4 x plus 2, x plus 1, x minus 1, and x minus 3. Might be one last one to go. No, there isn't. 1/4 x plus 1 minus 1 minus 3 plus 2 plus 1 minus 1 minus 3 minus 2. So you can see we're getting them right there. Negative 1/16 x plus 4, x minus 3, and x plus 2. 4 minus 3, negative 2, negative 1/16. You can go through and check the others, but I'm sure they look like what we were supposed to be getting. Hopefully that helps. All right.